So yeah, this topic of why does sweating cool you down? It comes up in physics and in biology. If we imagine that we just had, for simplicity's sake, like 5 molecules of water, or particles of water, whatever you want to call them. We're just going to keep it very simple. Now, they're all moving around in a liquid, but they're not necessarily all moving around at the same speed. So some might be going really fast, some might be going a little bit slow, some might be going sort of medium speed, right? And some might be going really, really fast. Now, the ones that are going the fastest, well, we can say 2 things about them. We can say, 1, they would have the most energy, and 2, they're the most likely ones to evaporate. They're the most likely ones to have the energy to leave the rest of the water droplet, right? So this one here, this one's going to leave the water droplet. So this is like a very small water droplet, I guess I've drawn here. And so it's just going to just shoot off like that. And it's left the water droplet, right? Now, originally, if we say that how fast these particles are going, we might want to actually give them a number that might represent the amount of energy. So this one's very, very small. We'll just say that had a unit of 1 energy. We won't worry about the official units at this point. This one has 2, and this one has 3, this one has 4, and this one has 5. So before the fast one left the rest of them, the total amount of energy, because obviously they will keep sharing energy between them. Like if this one bangs into this one over here, then it might lose a bit of energy. The other ones might gain a bit of energy. So we have 1, 2, 3, 4, and 5 units of energy. Sorry, 5 different particles with that many different amounts of energy. So the total amount of energy would be 1 plus 2 in this example, plus 3 plus 4. Oh dear. Plus 5. Oh, my pen's being a bit strange. 5. Okay, so that's 9. That makes it to 12. And that makes it to 15. Okay, so I added up that right, didn't I? Yeah, 15. Okay, so the total's 15. And if we average that out, then that would be an average of 3 units per particle, right? 3 per particle. Now, that meant that when the fastest one left the group, it took more than its fair share of energy, and it's designed that way. It always would. So because it's the faster ones that are the ones that do move, that do leave. So now we've got 2, then 6, 7. We've got 10. 10. Oh, I could have done 15. Take away 5, but we've got 10 now. So now it's 2.5 units per particle. So the energy per particle has dropped. So the average particle has now less energy than before that one left the bundle. And temperature is defined as the kinetic energy, the average kinetic energy. That's what it means. So it's the average kinetic energy. Oops, kinetic energy. So evaporation reduces the average kinetic energy, which means it reduces the temperature. So that's why evaporation causes a cooling effect.